George Mitchell spent more than a decade experimenting with hydraulic fracturing techniques in the Barnett Shale in Texas, hoping to find a more efficient and effective way to extract natural gas. Oil and gas companies had tried and failed to make the technique work in the years prior, and Mitchell's efforts were widely dismissed as a waste of time and money. That is, until he perfected the technique. It was rapidly adopted industry-wide and resulted in the U.S. shale boom that rearranged global geopolitics and ushered in an era of unprecedented energy security for the United States, taking the world by surprise. As pioneering teams charge into the field, experimenting with novel, scalable geothermal concepts, many in sedimentary formations leveraging the very techniques that Mitchell pioneered, the parallels between the shale boom and the coming geothermal boom are clear. But entities on the sidelines, including big oil and institutional investors alike, are awaiting one thing before jumping in: field data. In the coming sessions, we have invited startup teams who have deployed new concepts, techniques, and technologies in the field this past year, and who have agreed to discuss previously unreported data and outcomes. So sit back, get your questions ready for the teams, and see if you can spot a geothermal George Mitchell.
Hey, everybody. Jamie B. from Project Inner Space. Last was awesome. How did you guys like? Pretty cool. So I remember back in 2020 when we started Pivot, it was really hard to get people from the oil and gas industry to talk on the record about geothermal. And they did. It was, the understanding was it would be vague and we wouldn't talk about what the entities were doing in particular. It was all hypothetical. Oh my gosh, look at how much that's changed in 2 years. I love it. It just absolutely makes me so excited. All right, so this next session, one of the big points of feedback about Pivot last year was this also, it all sounds great. There's a lot of talking, but what about action? We need data. We want to see data. What about what's going on in the field? So today is all about the data. And we're going to start digging in. So we're going to talk about, how we can use existing data in the seismicity section. We're going to talk about datathons, so using data for modeling. And then in this next session, we're going to talk about field data. So there are 4 startup companies that have gotten out into the field. They have some new results to report. And so without further ado, let's dig into that. Please ask a lot of questions. The point of this session is to engage with these companies and ask them questions. So please use that blue bottom of your screen to send, and I'll be back to analysts after their presentations. With NOV.
Thanks a lot, Jamie, and good morning and good afternoon and even good evening to a few people out there in the Far East. So this is really exciting for me to talk about particle impact drilling. And myself and John here have taken a journey over the last year or so, and we're really excited about the impact that this could have on geothermal and blowing some holes in very hard rock very fast. Yeah. So the first question, what is particle impact drilling? It is very straightforward, really. It is taking high density steel shot, the commodity item that any of us would use in a shop peening shop around the world to clean tools, etc. And we inject it into the flow line in between the pumps and the top drive. Those steel balls pass down the hole, and they accelerate into the drill bit particle accelerator. So as they accelerate into that, they accelerate up to 500 feet a second, and just sheer unadulterated physics means that we get 12 million impacts per minute at 500 feet a second coming out of the bit. So we literally blow away the rock. Yeah. Total volume is 2 to 3%. Simple technology. But the fantastic thing in this is that theoretical ROP is greater than 120 feet an hour, 40 meters an hour to those of you in metric. So this is has the potential to drill, significantly faster than any of the best PDC technology out there in the world at the moment. So it's straightforward, yeah. So you can see from the images on the screen, we have effectively a large particle processing unit, which looks like a cement mixer that you would see on the highway filling up the concrete. We then have a particle injection unit, which has 3 high pressure cylinders in it that we sequentially fill with the steel shot. So one will be injecting, one is on standby, one is getting refilled. We then have a control monitoring cabin where the whole process is controlled, and this is been through all the checks and tests and is fully commercial and operational. And then those of you who are thinking about, what happens to the steel shot when it comes around and back out of the hole again, we have a triple decker shaker. So we're typically going to get little arrowhead pieces of granite that are the little peaks that will break off. We'll get the arrowheads, they'll come across the top shaker. We'll get the steel shot coming across the middle shaker, and we'll have the fine broken up feldspar and quartzite coming across the bottom shaker. So nearly all of the shot is recycled and re-injected and pumped around the hole. Is the other simplicity of this is how simple it is. Yeah, some questions came up in the last session. What does a geothermal rig look like? Yeah, and really we can take any land rig anywhere in the world. Ourselves, we went and drilled with an old Kelly rig when we were testing this technology, but we can go with a sophisticated So the journey we took, which is a really nice story. Again, previous session just had a whole bunch of service companies, and it was good to hear the investments that the different service companies are making in supporting and growing the startups. So NOV, we met Particle Drilling last year, and we put a joint workshop partnership in place because we really wanted to sort of take a look at the challenges, which was to try and make the particle drilling head, which John and his team knew could drill fast, but you wanted to make sure that the head survived and didn't become the limiting factor. Yeah. So when we put our heads together and we looked at the technology, we saw, right, why don't we combine the latest PDC technology with the drilling methodology, which is continuous. Yeah, keep adding steel shot to the hole means that if we can keep the diamond lasting, then we can keep injecting more and more steel, and the bit runs get longer and longer and longer. Yeah. So we looked at the external design and came up with a plan to have a particle pilot and then a diamond reamer. So in the images on the screen, the little grayed out area is kind of showing you the rock that is being removed by the particles, and then the remaining part of the hole that's going to be opened up by the PDC. So by having the PDC on the side, what it did is we really cut out that lateral and torsional vibration that was damaging the sides of the particle drilling heads. Yeah, so we've got that. The other challenge that the guys have had for a long time was really being able to know when they were touching the bottom or not. Yeah, so now if the ballistic head that you see on the front of the bit touches the bottom, it lifts the diamond cutters off the side of the hole and you lose torque. So now you know, oh, we're going slightly too fast here. Let's back off for a little bit and we'll drill ahead using rate of penetration. That's the only time any oil and gas people are about to put their shotgun shells and shoot me for saying I'm drilling with ROP and not with weight on bit. We don't need any weight on bit here. Yeah, we're drilling with shot. Yeah, so we have to drill with ROP and use the reamer to gauge what we're doing. Yeah. So onto the data, and so we designed one of these bits, and this is, you know, the thing that Jamie's been whipping us all about has been speed. Yeah, we all got to get, you know, moving to get this geothermal bandwagon moving faster, and we really went from first conversation to lab tests in 4 months. Yeah, it was fantastic. Yeah. So the images you got on the picture show are from different lab tests that we did in the drilling lab in Conroe. So the first 2 tests, we just wanted to we didn't bring the reamer into contact with the rock slab that we had in the drilling lab. We just wanted to see what the bottom hole pattern was doing. We then did a third test at 60 RPM with 2,000 to 3,000 pounds, and we were doing 50 feet average, but we could get up to 150 feet an hour instantaneous. Yeah. Fourth test, 8,000 pounds with an ROP of 100 feet an hour. This is what we want. We're really getting up there into those speeds that make a huge economic difference to geothermal. And the fifth test was just nice steady state, 4 to 5, and we got 75 feet an hour. And you can see from the images that the bottom hole pattern rings that are produced from the particles, and then you can see in the top left image the kind of pattern that the reamer creates in removing the remaining bit of the rock. Yeah. So the internals, basically the design is most of the rock is removed by the particles, because we don't want to be limited by PDC. We then had to engineer the internal flow paths to make sure that the particles are not eroding the bit from the inside to the outside. Yeah. So every bit of fluid dynamics design stuff there is to minimize any internal erosion. Again, we don't want that to become the Achilles heel of the product. So it's all very smooth flow paths inside of the bit. So the next step was to go and find a hole to drill. And unfortunately, we couldn't find any of you geothermal gang drilling granite at that time in Texas or in the United States. We had to go and find our own well. So a quarry owner in Central Texas, who John knows, lent us his quarry. So we were hanging out there with the people cutting countertops for the kitchens, and we spudded into 45 kpsi pink granite. Yeah. So those of you who are not geologists, this stuff is huge quartz phenocryst. It's got veining through it. It's got large mineralization. So it really is dynamically very hard to drill through. Yeah. We ran 2 particle drilling hybrids in it, and each one did roughly 450 feet. So the total footage was 980 feet and 298 meters at 43 feet an hour or 13 meters an hour. For us, straight out of the box, we felt really pleased with this. We also, all drilling trial and error, we pretty well knew what we could do to improve version 2. Yeah, we had some simple challenges that we spudded into granite. Yeah, even the first literally few hundred feet, we had to get as many collars in the hole as we can to get any weight on bit on the reamer. So it was dynamically active. Those of you who understand that low weight on bit tends to create some lateral vibration. So we had some challenges that would be not there if we were probably spudding in at 5,000 feet and already had a decent amount of well behind us. Yeah. But you can see from the images, and one of the curious ones, you know, the nose is pretty beaten up and it's quite eroded. Yeah. But one of the nozzles that hasn't touched the bottom shows no erosion. Yeah. So there was a sort of ding moment, you know, what's going on here with the nozzles, because the material that they're made of seems to be outliving the matrix that the bit was made of. Yeah. So that, you know, as we cut the bit apart and dug into the challenges that we saw, we thought, right, okay, number one, let's change the material of the body. Yeah. So let's go from TMS matrix to cast carbide, which is pretty well the sort of toughest material that you can make a PDC bit of. Okay. We didn't really have problems, but to improve manufacturability, we went to one-piece nozzles and accelerator sleeves inside. So they're you know, 6-inch long nozzles inside the bit. We saw damage on the PDC cutters, probably because the radius was too aggressive. Yeah. So we've opened up the radius so that we got more diamond in there. You know, an instant upgrade as well would be to take the best cutters from Forge and put you know, shape cutters in there, more diamond, because, you know, we, relative to a normal PDC bit, this has relatively low cutter count in it, so we could afford to put some diamond in there and just make this thing last longer. Yeah. We made the nose, if you look at the right and the left diagrams between the 29 and the 33, you can see that the new one's more ballistic. Yeah. So that's to, when the steel shot ricochets off the bottom, that is to make it sort of bounce off to the side. Yeah. So we want to minimize as much, we want glancing blows, not direct impact. Yeah. So again, if with the combination of the cast carbide and the new shape, we believe this will last significantly longer. So we want to take version 2 out there. And we believe if we, you know, from what we learned from well 1, what we saw in well 1 with the redesign, we'd like to think that we could boldly do 1,000 feet, 60 feet an hour, even potentially a little bit of sandbagging in that number. Yeah. So anyway, we need to test well ASAP. So someone who's drilling something hard in the United States, please give us a hole. Yeah. And that is the end of the formal part of the presentation. So we open it up to the floor, to all the drillers out there for a Q&A for John and me. Thanks a lot.
Hey, everybody. All right, so we are going to transition into the Q&A portion of the session. If you will look at the bottom of your screen, you'll see a blue bar if you have questions for Tony. And we're also going to welcome John Schiller Drilling to the stage to address Q&A. So we'll go ahead and get started. We have about 15 minutes to run through the questions, and there are already quite a few. All right, so let's get started. Tony. Oh boy, there's a huge list. All right. So let's get started. What about the steel shot? Does it help or hurt with your fracture losses?
This is a good question, and I'll open up, and John can add to it. Yeah. So, you know, fundamentally, so number one, these are 2 millimeter round balls that if you get them in your cracks and you're drilling a traditional hydrothermal well, they're not going to impede the flow in your well. They're like the perfect proppant to put into the wellbore. On the loss side, John, do you want to talk a little bit about, you know, if we lose them, the cost or and etc. Yeah.
Yeah, exactly. I mean, the issue is going to be the lost circulation. If we can live with some lost circulation, we can control it as you would in any drilling situation. If you're going to have massive loss circulation, we're going to lose a lot of our shot, and that can become an economic issue more so than a drilling issue.
And what's the rough cost per ton, John? It's not brutal, you know. It's less than the cost of oil-based mud, yeah.
Yeah, no, it's nowhere near where oil-based mud is. Really, it's more about the logistics of making sure we're ready for that type of loss on location.
All right, let's hop to the next one. What happens in an extended pump shutdown? Does the shot plug up the bit?
Yeah, so we have different procedures depending on what happens on the rig. But if you were to lose total pumps, which is like we've actually had that happen when we were test drilling in East Texas, we basically, you got to trip the pipe up off the bottom of the hole. The slip velocity on these things is about 60. And so you'll have your shot start working its way down the bottom on both the outside and the inside. The idea is to pull up where you can keep fluid flowing through the bottom of your bit. And then once you've got pump circulation back, you can wash the bottom just like you would with any other lubricating beads, etc. The shot itself washes out of the hole pretty easily.
We got some good comments here. There's a comment, excellent initiative. Can you disclose some numbers with regard to how much more effective this drill bit is compared with current industry gold standard drilling? So yeah, what about that?
Yeah, that's a cool question. So what we did do, which we didn't have on the slide, was immediately after our last particle run in Marble Falls, we ran the groundbreaking PDC that Reed Heikelogger designed and run in Forger, and we pretty well pulled it out 4.4, totally worn out after 122 feet. Yeah, so we were already 3 times the distance, and you know, matching the very starting ROP of that PDC. Yeah. And the PDC, everyone who's looked at the Forge data that's been out in the public domain, is once you get a wear flat, you drop quite significantly down, and you hold a long steady tail on that PDC. Obviously, we're working on, we want to steal that technology and put it in the shoulder of our bit, so we want them to be successful as well. But you know, the reality of this, the you know, a relatively conservative number is it should be 5 times faster than the best PDC out there. Yeah.
Awesome. Here's a 2-part question. What percentage of the particles are you recovering and research? And what are your thoughts on the benefits of this technique in rocks versus igneous formations?
You do that, John. Yeah.
Yeah. So we recover 99.5%. We'll lose about 0.5%, which is basically breakage as we drill. Most of the breakage we actually recover at the surface through the triple shaker, as Tony was describing it a while ago. So all the shot stays out of the system. It never sees the pumps. It's always in the circulation system. You know, can a little bit bounce into a mud tank as it's coming out possibly, but at 2 to 3% volumes, we've seen very little shot actually left in the hole. What's left in the hole is usually embedded into the side of the formation. And Jamie, you broke up on the second part. What was the second part of that question?
What are the benefits in sedimentary rocks versus igneous formations?
Yeah, so I was paying attention. One of the presenters yesterday during the sedimentary session were actually involved on a DOE grant request. What we've seen is we can drill hard or soft rock with the shot. We've actually done that some in East Texas. So one of the biggest advantages we think of the system, as you go through interbedded rock, we're going to prove a lot more advantageous to you than what a normal PDC bit would do in those situations. The harder the rock, you look at the physics that Tony laid out for you at the start, the harder the rock, the more P rate, but we don't, you know, dramatically change because the rock's somewhat softer.
Next question, what type of fluid are you circulating?
We typically are using regular drilling muds. We're looking for viscosity, yield points in sort of the 15 to 16, just to help with the shot suspension in case issues occur like we were discussing earlier with one of the other questions.
All right, audience, keep in mind, I am an attorney and not a driller. So there are so many, there's like word, letter soup in these questions. Some of them I'll be able to answer, others I'll just read them word for word. So you guys will know what they mean. Which are the BHA limitations of this technology in terms of monitoring while drilling, directional drilling, tools, etc.?
Okay, I'll do a stab on that one. So for directional drilling, we started going through a whole range of experiments and tests to see what the impact was. And first thing we did was mud motors. So we put NOV dyno, a mud motor in a dyno, and pump shot through it for 120 hours. In that time, we saw, yes, there was erosion to the mud motor, but relatively low for how you see that the damage that it does to rock. So as it was going through the rotor and stator, it was causing erosion, as does sand and other solids in the mud system. But we continue to have a working motor. That's first thing. On MWD tools, there's got to be a simple philosophy. You need a relatively large flow area for the particles to go through. If they're going through a relatively large flow area, the damage is minimal, and also as long as they don't change direction rapidly in passing through the tool. So we looked at survey on demand tools, relatively straightforward. The tool's asleep, then you take a survey. Now that doesn't help you if you want to steer. So if you want to steer, we're going to have to look at probe-based EM tools and or negative pulse tools with some degree of protection over the negative pulse orifice to prevent the beads from getting into the orifice. All engineering challenges, but none of them insurmountable. If you put a downhole powered tool in there with a turbine blades on the bottom of it, we won't have a turbine blade on the bottom of that tool. So it's about selecting the right tool fit for purpose, which is, the good thing is most land rigs tend to use more simple tools. EM tools would work no problem whatsoever, because they have no pulsar or power. They're battery powered and no pulsar. So we're working through those challenges. Good question, though. Very good question.
And I'm going to start grouping questions a little bit because there are a lot, and I'll let you know, audience. Tony and John may join the audience after our session, and you're able to ask them questions directly through the chat in the audience. So you can do that. There's a way to engage with other audience members on the platform if we don't get to your question. So another one for you all: is the bit steerable, or can it be made steerable?
I'll address it. So if you and John add to it, so if you put a bend onto a motor, you're now pointing those steel shot in the direction in which you want to go. I'm probably one of the few directional drillers who's actually jetted a sidetrack. And effectively that is exactly what we're doing. If you point it, it's going to cut a hole in the direction in which you point it. So it actually could be an absolute directional driller's dream, because if you're drilling a lateral and you can't get weight to the bit, we don't care. We'll just trundle along and point it in the way, and we'll literally blow it out of the way. So again, get us a well, and we'd really like to do some of these things in really hard rocks, because the other benefit is we've got ball bearings lying all over the low side of the hole as well. So we've lubricated the string with our drilling material. So it does have good directional potential.
We only have time for. Yeah, please go ahead, John.
You're the old directional hand. I wasn't going to add much, but you made a great point, and it's not necessarily easy to see in the pictures, but with that reamer section on top, all our particles do is go straight out, and they're going to drill their 8 inches of hole. They're never going to get diverted. They're never going to try and kick you to the side. All they care about is 3 to 4 inches in front of the bit, and that's what they're drilling. That's why you saw the hole patterns that he shows you. So to the point Tony's made, point us where you want to go, and we're going to keep that build going. We're going to do everything you need.
Yeah. Yeah, you're going to have to think about your 3-point geometry. So it is going to be from the last diamond cutter on the back of the bit, the touchpad or near bit stabilizer, and then a stabilizer above, and that will give you your curve, and it will literally follow that curve, probably more mathematically than you would normally get from a 3 points of contact with a regular directional assembly, which is susceptible to changes in weight. Yeah.
Yeah, we're running out of time. I'm going to give you another an easy answer 2-part question, and then give you a minute each to say a closing and what's next for the technology. And then if you'll join the audience, there are so many questions here. We didn't get to even 5% of them. What is the temperature limit for the bit, if you know it? And do you expect the bit to reduce the volume of water or fluid used in conventional drilling methods?
No theoretical limit. It's a carbide cast bit on temperature, so it's whatever going to melt still, and no difference on fluid for the mud.
Yeah, exactly that. No, there's no, unless you were going directional, and then you would have limitation. But I think we've seen in previous, in recent stuff that there's metal on metal motors out there. But yeah, the particle drilling itself will not be a limitation to the temperature. There will be lots of other things in there that are limiting factors, but we won't be that limit. Yeah.
And did you address bit lifetime already, and I missed it?
Sort of, yeah. I mean, lifetime will be fundamentally as long as we can keep that reamer lasting. Yeah. You know, in iterations coming up, you know, maybe we have to jump. Rather than doing 3 or 4 iterations, maybe we just throw a huge amount of diamond on it and just go for one exceptionally long run, because it's not really going to slow you down, because the particles are drilling the bulk of the rock. Yep.
All right, thanks audience for all this engagement. This is amazing. I'd like to take the last minute of the session here to give Tony and John a minute to talk about next steps. I know you all are looking for a way to deploy, but you know, what's the next iteration? What are your plans? What are your next steps for deployment? And then we'll connect you back in with the audience so you can engage with some of these other questions. Tony, why don't you go first?
Yeah, I'll go first, and I'll let John close out as the CEO of Particle Drilling. Yeah. So we have a fantastic relationship between the two of us. It's a collaborative partnership. We really chuck all of NOV's energy and enthusiasm into the bit that we're experts in, which is the diamond drill bit technology, taking what we're learning from Forge and other geothermal projects and applying it to particle drilling. From what I've seen in the 18 months, this technology really, you know, needs as much field testing and running as possible. But remember, it is commercial. Yeah, we can go and drill, you know, 1,000, 2,000 feet of granite right now. Yeah, it isn't, you know, millimeter wave, and it isn't, you know, all those technologies have their place in geothermal over the next decade. We have our place in geothermal over the next month. Yeah, so let's get some holes. Yeah, John.
What do you think, John?
Well, I think Tony summarized well. The collaboration between the two companies, what it really did is, prior to putting his reamer PDC onto our bit, we used to refer to our bit as a nozzle carrier, because at the end of the day, as long as we have nozzles accelerating that shot to 500 feet a second, which is all a function of pump capacity, we're going to drill hole. And so, yes, theoretically, we can go a long way. We're ready to go. We've designed and utilized bits from 6 to 8.5, 8 3/4. We've got the design for 12 1/4 ready. The engineering has been done. We're just ready to build it. So we're just working with several companies right now, but we'd like to get out there and get the work on a true geothermal well as opposed to surface quarry or deep, but we've also done some deep work on the Travis Peak in Cotton Valley in East Texas.
Awesome. Hey, Tony and John, thanks so much. And you guys are leading the way. So thanks for the push on this. This is amazing stuff. If you audience, if you want to back more with John and Tony, they'll be part of the audience in a little bit, so you can do that via chat. Thanks so much. So we're going to take and we'll be back with our next startup. Tony and John, you guys rock. Thanks so much.
Thanks, Jamie.